Meet our presenter, a curious learner who is tired of studying without results. She opens a book titled The Science-Backed Best Study Methods and wonders, could this change everything? She recalls the frustration of spending hours highlighting and rereading, only to forget everything during the test. It's time to break the cycle and study smarter. The book starts by dismantling 4 common methods: rereading, highlighting, copying notes, and tailoring study to your learning style. These are less effective than we think. Research shows that simply rereading creates a false sense of understanding. Our brain tricks us into thinking we've mastered the content because it feels familiar. The next ineffective method is copying notes. Neatly transcribed summaries may feel productive, but unless you engage with the content, it doesn't boost retention. Highlighting can also be misleading. Marking key phrases feels satisfying, but studies show it doesn't improve test performance unless paired with deeper processing. And about learning styles, visual, auditory, etc., there's little scientific evidence supporting better outcomes by matching study methods to those preferences. The presenter feels a bit shocked, so many hours spent on methods that don't work. But the book gives her hope by introducing strategies that do. The first powerful method, active recall. It means retrieving information from memory without looking, like solving a quiz, summarizing aloud, or explaining to others. She writes key concepts from memory on a blank page, checks her mistakes, then revisits them later. It feels harder than reading, but her recall improves noticeably. Next comes spaced repetition. Instead of cramming all at once, she schedules reviews over days and weeks, reinforcing the knowledge as it starts to fade. She creates a simple schedule. Day 1 recall, Day 3 review, Day 7 repeat. This helps her brain encode the information more deeply into long-term memory. Then she discovers elaborative interrogation, asking why and how to force deeper understanding. It turns passive reading into active mental engagement. She tries this with biology. Why does the stomach secrete acid? The question pushes her to connect facts, building a more robust mental network. Another useful approach is self-explanation. She teaches herself the material, talks out loud, and reflects on how the new knowledge relates to what she already knows. Even when she doesn't fully understand something, trying to explain it makes her realize what she needs to study more. It's a mirror for her thinking. The final method is interleaving, mixing different topics or problem types together rather than practicing one in isolation. It trains the brain to choose the right strategy. For example, she mixes math problems, geometry, algebra, statistics, forcing herself to recall not just answers, but which approach to use. This builds flexibility. The studies are clear. Students who use interleaving may feel it's harder, but they perform significantly better on real-world tests weeks later. In the end, our presenter looks back and smiles. The science is clear. Smart studying is active, spaced, effortful, and reflective. She's ready to learn better than ever.